Hello everyone, I am Moshir Rahman and today I'll be talking about component diagrams. So let us first understand what component diagrams are. So basically component diagrams are used in modeling the physical aspects of an object-oriented system. A component diagram actually breaks down the whole system that is under development into various levels of functionality. Each of the components are responsible for a specific functionality within the entire system, and the component represents how each of these component diagram represents how each of these components are dependent on each other and how they interact with each other to actually form a system as a whole. Now let us discuss in details what each of these components actually represent. Components are an autonomous unit within a system, and by autonomous I mean that they are individual units performing a specific set of functionalities within the system. The components can be a software component such as a database or user interface, or it may be a hardware component such as a circuit, microchip, or a device, or even a whole business unit such as a supplier unit, a payroll unit, or a shipping unit. So basically, components actually hide the implementation details, and it focuses on three things: on the interfaces that it provides, on the point of interaction with its environment, and the usage dependencies. So before we dive deeper into each of these elements, let's understand the notation of the components first. So there are basically three types of notation for each of the components. In the first type, we can see that there is first this is the first part of the component where which represents the stereotype of a component, and underneath that there would be a name of a component. So stereotypes are basically the parts that's within double angle brackets. This is a stereotype. This defines the type of component, and underneath that we just write the name of the component. So this is one type of representation. Another type of representation is where we use a component icon in the top right corner and then write the name of the component in the middle. Or we could also, in the third type of representation, we could also use the component icon and use only the stereotype on the stereotype only. Now let us look at the component elements. What elements that are important for each component. So first one is the interfaces. So interfaces are basically represents the set of operations for the components. Then there is the usage dependencies, which actually represents a relationship, or where one element may require another for its full implementation. Third one is ports, which acts as an interaction point for extending a component's internal interfaces. And finally, there are connectors, which actually connects two components through the interfaces. Now, the first element is the interface, and interface basically defines the behavior of a component. Each interface has a collection of operations defined in it. Interfaces determines the type of data that's flowing in or out of it. Interfaces are also the connecting points of two or more components. A component may have two types of interfaces depending on whether it needs something from other components or provides something to other components. And those two types are provided interface and required interface. Now, as the name suggests, the provided interface actually provides a set of services or operations to other components. So this actually means that a component produces some outputs based on the internal implementation or based on its functionalities that's defined for that component, and it is modeled using a ball and labeled with the name attached by a solid line to the component. So this is the representation over here. So this is the provider interface part, where this is the ball notation. On the top we define the type of interface or operations that this component provides, and another one is the required interface, where it declares a set of services or operations that a component will need. So basically, it is represented using a socket notation and labeled with a name on top, and also attached by the solid line to the component. So the required interface basically tells other component to provide this type of operations, so that it can complete the implementation of these operations. So over here we can see that the order component requires a person interface in order to fully implement the functionality of all of the order module or order component. When two components actually provide and require the same type of interface, then these two notations may be combined. So as you can see, over here we have this ball socket notation. So the manager requires this interface, and the course provides this interface to the manager. Also, there may be some cases where multiple components require or provide a similar interface. In that case, as shown in the diagram, all we have to do is we need to connect multiple components together through a line, and a single ball notation is used for connecting it to another interface that requires this interface. Next, we have usage dependency. This is a type of relationship which defines that a component or a package or any element in the class in the component diagram would require another element for its full implementation. So basically what that means is whenever we are importing something for implementing a certain piece of functionality, so that importing part, the part where we're importing, that part is represented using usage dependency. So we are basically depending on the imported package to complete our full implementation, and that's why we say that the import we are our implementation is dependent on that imported package. So we may import on various occasions, like when we are using some external packages or external gateways to in order to implement a certain functionality within the element or a component. Next, we have port. So port is basically an interaction point or an extension point for the component. So basically, ports define the interaction point between component and its environment. By environment, I mean outside the boundary of a component, or a component and its internal parts. And ports also have visibility. When a port is drawn over the boundary of a component, that means the port is public, and if it is drawn inside, then it is either protected or private. So to better understand, let us look at a diagram. So this is a component, and inside this component there are multiple subcomponents. This is also possible. A component may have multiple subcomponents within itself. And over here, this is the port, which is basically an extension point, or we can say the interaction point for an interface. So basically, and when an interface needs to be extended outside the component, then we use port to connect an interface to its outer environment. So basically, ports expose an interface to its outer environment, or expose the internal interfaces to the outer environment, so that the internal components can work properly through the implementation details that's being provided by an external component or another component. Next, we have connectors. So basically, there are two types of connector. One is an assembly connector, another is a delegation connector. So assembly connector is where two components define that one component provides, another component requires. So we have already looked at this type of connector when the same interface is required by a component and the same interface is provided by another component. So they are connected together through an assembly connector, and this notation is a ball socket connection. Multiple connections may be derived, so we have also looked at this when we discussed about the provided and required interface. So when multiple components provide the same interface, then they're connected to the same line, and and similarly, when multiple component can require the same interface. In that case, it would be the same as well. Now, delegation connector are basically when we are delegating an internal interface to its outer environment through ports. So it's a way of how it's a way where component which has multiple subcomponents within itself, and that outer component needs to expose a certain number of interfaces in order for its internal components to work properly. In that case, we use delegation connector. So over here, this line through which this interface are being delegated through the port to an outer interface or outer environment, so that another component can provide or may require a certain interface. So that's how internal components exposes their interfaces to to other components outside the parent component. So that's how connectors work in general. Now finally we have dependency relation. So these are different type of relation compared to the ones that we have already seen. So dependency relation is basically when a component is dependent on data from another component. So this relationship is based on data only. So whenever a component requires data from another component, and not not any other thing, like another interface that would provide certain operations, so nothing like that, it just needs data. So in that case we use dependency relation. So in case of dependency relation, as you can see, provided interface over here receives data from an online shopping database, and we have a dotted arrow pointing towards it in order to represent that relationship. So whenever a component requires data from another component, we use this type of relation, and and the arrow moves from the part which is providing data to the component which actually receives the data. Here is another example where we have an account interface, where an account component and an order component. Over here, the account detail interface or account component provides account detail related information or data to the payment interface. So basically, they do not actually implement the same interface together, but the payment interface takes data from the account detail interface, all the related information related to the account, and uses that in the order component. So that's how the dependence relation works.